has anybody been outside? It's like frigid. I had to go pick up my son and I was like, oh my gosh, it is freezing outside. Hi, Maricruz. My goodness. Hi, Michael. Yeah, it is so cold. It feels like snow. Hi, Faisal. Hi, Aaliyah. So I feel like, I don't know, we should like take bets. Like, do we think it's actually going to snow this week or not? I'm like feeling it's like cold, like it's going to be snow. Yeah, the wind, they said tomorrow the wind chill it's supposed to be like in the teens, like 18 degrees. Whew, that is that is cold. Okay, let me do my entire screen. Let me see. Hi, Ashlyn. Go back to my starting slide. Wherever they may be. There we go. Hi, Gabe. Okay, is my screen like flashing? Oh, yay. Okay. All right, guys. Tuesday the 9th. I can't even believe it. We are going to be doing your second part of your notes, so the explain section of your notebook. Yesterday, you guys got to do the Gizmo where you introduced kind of the stages of protein synthesis. So we're going to dive in a little bit deeper and add more to it. So it's kind of, remember, it's like that layered effect. Tomorrow, for sure, we're going to be going through, I'll use my dot cam. Hi, Shapreet. I'll use my dot cam. We're going to be taking some more. Hi, Corey. We're going to take some more. I'll do some diagramming. We'll kind of pull everything together. So if yesterday you were like, feeling a little confused, lots of vocab, new terms and everything, no worries. Today we'll add on to that. So you're going to be doing an within the Nearpod that you guys have. There's an interactive tutorial, so it's going to be like an interactive notes thing. There is a short little reading and then a short video that's a part of that. Okay, so it'll start to come together, and then tomorrow we're going to take our little scenario that we were using and we're going to pull it all in, and then we're going to go through a couple simulations together as a class to kind of pull everything in. Remembering your test is on Friday for the unit, which means your notebook is also going to be due over the weekend as well. I put your quizzes in the grade book. It was one of those things like you guys really did really well, or if you missed Friday's class, you were like, oh, and then you went back and took it. I could definitely tell. You're like, oh, yeah, definitely missed that class, and that was an important one to be there for, to make sure that you guys were successful. So it's currently in the gradebook as a no count. However, if you are pleased with your score, you're like, heck yeah, I am proud of that score, I'm going to give you guys an exit ticket for tomorrow. So just to let you know, if you're looking in the gradebook and you're like, but I really was proud of my score, I'm going to give you an exit ticket tomorrow to see where you guys are at. And on one of the questions, it's going to ask you, do you want to count your mini quiz score in the grade book? And you'll say yes or no. And I'm going to use that. And then I will I will count it if you say yes, or I won't if you say no. So with quizzes, it's going to be one of those things where I want you guys to use it as a study tool. I did release your scores to you, so you can see what you got, what you missed. I apologize, like I said before, that one or two of the questions got flipped up. There was a typo on the parts of the nucleotide question. So for those of you who caught that, it was the parts of the nucleotide are the phosphate group, the sugar, and the nitrogen base. I accidentally put the phosphate group sugar nucleotide is what I did. So thank you to Ricky, who jumped back on the Google Classroom to let me know that that was a typo. For those of you who had put that one, I changed the option mid-test, but I went back in and gave you guys the points if you had originally selected that one. So if you were going through and you're like, my quiz looks really super weird, that's why. So I apologize for that like weird glitch that was going on there. Same thing with the very last question. When you were selecting the things that were either DNA, RNA, or both, it was the formatting of the question that was selected by the teacher who made this. It was not, it was like weird. So I had to go mid-test and change the options. But again, I went and scored that question in like on my own. So I corrected it for you guys. So take a look at your quiz results from the quiz last Friday. If you still haven't taken it, I think I still have 6 people who need to take it. That is in the gradebook as a 0. As an incentive, you have to go take it. Okay, so you see a 0 in your in Skyward right now, it just means I'm trying to get you to go take that quiz. So make sure you go in and do that. It is still linked in Google Classroom. But overall, tomorrow I'm going to have you guys decide after you go through and look at your quiz if you want to count it towards your grade or not. Questions about that? Okay, so for my opening question, or questions, I have 2. Basic, like, just what do you think these words mean? You can use Google. Just what does the word to transcribe mean, just definition wise? So what does transcribe mean? You can use Google, just like, what does transcribe mean? You can ask Alexa, you can ask Siri. What does it mean? What does transcribe mean? Okay, so Raven's got to put words or thoughts into a printed form. If you agree, okay, to write something, yeah, basically, yeah, it's to write something down, copy something. Okay, so way back in like Egyptian times, they had scribes. Their job was to like write down history, to copy things, to copy the events of like the culture. Okay, so when we start getting into protein synthesis and start looking at what is going on in each of the phases of this massive process, I want you guys to kind of think about, what does the word mean? What does transcribe actually mean? Just in basic terms, to write something, to copy something down. Second, what does it mean to translate? Okay, and second, add that, how many of you guys are bilingual? Have that amazing skill of knowing more than one language, can speak more than one language? And if you can, tell me all the languages you can speak. I am forever impressed by this. What languages what do you guys speak? English and Spanish, Vietnamese and English. Oh man, I am super impressed, Jillian. English, Spanish, learning Japanese. Oh my gosh, Portuguese, English. You guys are rock stars. English and Russian, English. Sorry, back in Spanish. Oh my gosh. I do too. I wish I was bilingual. I took German in high school and a little bit in college, and I can pretty much ask you like, where's the bathroom? And same thing in Spanish. I can ask you how much something is and where's the bathroom, like basic. But props to you guys, for all of you who are like bilingual. I hope you know what a skill that is. Now, when you think about what it means, like if you had to translate something for somebody, like if you had to translate, like let's say like your grandparents or your parents are not as savvy with being bilingual, and you have to translate. I know I've sat in meetings before with parents maybe, and I've actually had the students who are translators for their parents, which was incredible to watch. Like, I want you to think about what you are actually doing in that process. So you are hearing one language and you are then changing certain things and recommunicating it into another. That is exactly what is going on during protein synthesis, okay? So when we start getting into these 2 major phases, I want you to think about what those 2 words actually mean. So yesterday, you were introduced to those major 2 phases if you did that activity. The first being transcription, so the process of making copies or copying something down, writing something down. The way that your body makes a copy of something or writes something down is to make an mRNA. It's to make that messenger RNA. So when we go to model what transcription looks like, it's how your body makes an mRNA using base pair rules. translation, okay, remember we said that DNA and that messenger RNA, they can talk to each other, but there's certain things where you should have looked at yesterday and saying, okay, well, DNAs have T's, RNAs have U's. That's a huge translation, like almost like a language barrier between the DNAs and the RNAs. And the mRNA is our translator here. So during this process, when we go between the first stage of protein synthesis to the second stage, how does that transition happen? Okay, so we're going to be looking at that and diving in a little bit more of that today. Okay. Okay, so let's go over to slide number 7. I want to kind of walk through real quick. Did anybody have any questions from the Gizmo or anything that they got tripped up on yesterday? Okay, so when we started out, like you guys had this guy right here. So just to give you a quick overview on some of the vocab words that they were talking about. Remember, when you start out and distinguishing between the two molecules, remember you will always start out with DNA. Now, there was 2 major distinguishing factors that should have helped key you in that this was a DNA and not an RNA. First, it's double-stranded. Now, your big giveaway is that you have 2 backbones. So that phosphate sugar, phosphate sugar, phosphate sugar was on both sides of that molecule, telling you that it was double-stranded. So you had 2 backbones, and you had 2 sets of that nitrogen base here in the middle, okay? That's the first way. The second way is that we know that DNAs use A's, T's, C's, and G's. Only A's, T's, C's, and G's show up here in this middle section. RNA would have U's. There are no U's here, which means that I know process of elimination. I know that I'm not dealing with RNA yet, okay? So in your notebook, that first question, you know that your DNA, it's double-stranded and uses A, T, C, and G, okay? So just basic jumping off the board there. Remember, there's all those new vocabulary terms that are kind of introduced during this activity. Today, you'll be able to learn a little bit more about them. Questions for slide number 8. Okay. Now, when you are going through this, there's this big word right here, RNA polymerase. Now, don't be like alarmed by the name, okay? So if we broke this down and we looked at the word parts, so we see the first part is RNA. So usually in science, the name of a molecule is going to have something to do with what it's actually responsible for, what it does. So we know that RNA, so this big guy is going to have something to do with RNAs. A polymer, okay? The first part of the second word is polymer. And we know that the polymer is some sort of larger molecule made up of smaller pieces. Well, an RNA is a nucleic acid, okay? And an RNA is actually a form of a polymer made up of like smaller building blocks. That's your nucleotides. Now, ACE, that ending, those are always enzymes, which are a type of protein. And enzymes are responsible for building and breaking things down. So literally, this molecule that you are using, that's really important for getting this process started, is responsible for building these RNA polymers, or essentially building out the first RNA we're going to be using for protein synthesis, which just so happens to be, remember our little trick yesterday, whatever comes in alphabetical order. And M comes first. So we're going to be using our messenger RNA. So in your Gizmo, when you clicked that little RNA polymerase, remember your messenger RNA needs to make a copy, like literally like in a cell, write down the code. Well, this has to have access to it. Right now, this code is like all locked up. Because really what's happening is that your DNA is all twisted like a helix and squished in and it's all compacted. So we have to have a way to get at it. So this little enzyme right here, when you clicked it, its job is to break apart, remember, kind of undoing that Velcro or unzipping the code from itself. So it pulls apart the section of DNA that needs to be copied. That's what the RNA polymerase does, because now that RNA polymerase is going to start to help build out that RNA molecule, okay, the polymer. Now, when you start to build and we're going to make the copy, you use what you're making is a complementary strand. And that was kind of one of those words a couple of people put on their quiz is like, what vocab have you seen so far that gets you tripped up? Now, when you say something is complementary, it means it fits together. Like, oh, they complement each other very well. Well, in the nucleic acid world, when something complements each other, they fit, like the puzzle pieces we looked at the very beginning of the unit. So here we're looking at our base pairing rules. They don't extract DNA, Colin. I would say they open DNA. The enzymes in this case, because enzymes can do a lot of different things. This specific one is responsible for making an RNA molecule. So it helps to open the DNA, unzip it. It's involved, it helps in that process. So when you're looking at building this mRNA, you're going to use very similar base pair rules like we did before when you were putting your two DNA, you're building your DNA molecule together. Remember, A's and T's go together, C's and G's go together. But here's that trick. mRNA is bilingual, just like a lot of you guys are. Now, DNA speaks a very similar language. There are certain things that are very similar. So if you guys have ever in any of your languages, are there some words that there is just not it's not a straight translation, but there's things that are close. I think I've talked to some people, my friend is Russian, and I asked her, I was like, so, because she's a police officer, I was like, oh, so does that mean like, are you able to speak to like Ukrainian? Are you able to speak Ukrainian? She's like, a little bit. She's like, they're similar enough to where we can get by. That's kind of what is happening between the RNA and the DNA. The thing that RNAs, especially the rRNA and the tRNAs, don't understand is T's. This is like old world. Another example, think like when you guys are in English class and you guys have to listen to and read Shakespeare and all that really fun stuff. You're like, I don't understand what some of these words mean. Like this is, I mean, that's proper English, right? Old time English, old world English, okay? But it's not in use now. So what mRNA does is that when it goes through the process of making this copy, it has to think about how it's going to communicate, how it's going to be the translator to the rRNA who has to read this or listen to the message. So what it does is that when it's building out the code, it's going to make slight adjustments, just like what you would do if you were going to translate for somebody. You might hear something and say, oh, they're not going to understand that. So I'm going to change the word just slightly so that they do understand. That's what the U and the T's are. They're so similar, and the mRNA knows it, and so they'll make those adjustments. So when you are building out, okay, you're going to use your base pair rules. Now, an RNA knows, the RNA crew, they know what an A is, so they can put an A. So T's will still go with A on the RNA side. So what you're building is the RNA. Now here, okay, this is where the RNA doesn't know what a T is. And notice they are showing you like, okay, it's kind of similar in shape, similar in meaning. So they're going to go ahead and swap that T with a U. They still know what G's and C's are. So those are okay. Those are common. Same thing. So whenever the mRNA should be putting like a T there, oop, they're like, oh, my crew's not going to know what that means. I'm going to put a U instead. And so when they're building that guy out, they're making those minor adjustments. So whenever you see a T on the DNA, the T, they still know what the A is. So you'll still find an A on the RNA side. You just won't find any T's. Okay, so there's a lot of strategies you guys could use when you're building out that molecule. Okay, so you guys should have been able to put together this guy. Okay. So your thymine still bonds with A, adenine bonded with uracil, cytosine bonded with guanine, guanine bonded with cytosine, and in molecules of RNA, what you just built, uracil takes the place of a thymine. Okay. Okay. Now I'm going to leave the other parts to it. Actually, okay. Thanks, Vanessa. All right. Now for this, I'm going to kind of see how you guys do here on this practice one. So I'm going to jump to slide number 9 because I'm going to scan over your books a little bit. Now, when you get out, remember this RNA has to leave the nucleus. In this background, that's your nucleus. And you got to your ribosome. Now, there's no mention of rRNA in here, okay? And the reason being is that your rRNA that's going to read, remember, ribosomes are rRNA, so ribosomal RNA, ribosomes read. They're going to read the message, the translated message. They're going to translate this message of the mRNA, okay? They're embedded within this ribosome structure. They live in here. They're on the job site. Now, when this is read, the crazy part about what happens, and I'll show you some really cool videos, is that this is actually a two-part structure. It looks like a hamburger bun. So have you ever seen one of those massive like potato hamburger buns where it has like the small bottom and the big top? We call it the large subunit and the small subunit. They float separately around like this. They kind of like hover near each other. And when there's an mRNA that needs to be read, they clamp around it. They go whoop, and they clasp onto it. And then they like rip the mRNA through it. So it's like, and they read it like that. They like literally rip it through it. Now, where the mRNA was copied one nucleotide at a time, like one base at a time, one letter at a time, the way the ribosome is actually reading it, though, is 3 bases at a time. Okay, so where we would copy one letter at a time to make our words, they read it 3 letters at a time. And those little words that they're reading are called codons. So when you notice if when we start going through, you'll just start doing this too, is that when we start reading DNA codes, you'll kind of be sing-songy about it. You'll be like AUG, CUG, ACZ, UAG. You'll start singing them in like patterns of 3. That's a codon, okay? And that's how they're read. So they're read in these little 3-unit mini little words. And each one of those little words or codons is the instruction for one of the amino acids of the protein that they want to be, that needs to be built. Okay. So when you're looking at back at your notebook, okay, the crazy thing is that every protein that's ever made always starts with AUG. Okay, it's always AUG. And we call that our start codon. This tells the ribosome and the mRNA on the DNA where to start copying, and this means where to start making the protein. So all your proteins always start with AUG. It's like ready, set, go. So we start copying here and we start making our protein here. Okay, so you have AUG. Now, when the ribosome reads this, remember they're the boss of your tRNAs. This is the crew. Now, really what happens is the crew is really floating around out here. They kind of hang out around the ribosome. And they're literally calling out like AUG, AUG. And these tRNAs are hanging out. And this little ball section on top of the tRNA, that's the amino acid that they're carrying. It's like their supplies. So these guys are like just chilling out here and they're like, oh, that's me, that's me. Now, think about if you had something that you were having delivered to you that was really, really important. Now, think if you were having like a delivery sent to your house that was really important. Okay. What are some ways that they check to ensure that the delivery is properly made to you and not an imposter, or that they don't mess up a delivery to you? What are some things that they do, like in real life? They use barcodes, so they scan something. You have to sign for something. They check, right? If it's really important, they check. There is some sort of way that they're going to ensure that the delivery is proper and it doesn't get screwed up. Because if we screw this order of these amino acids up, it screws this protein up and it screws you up. We cannot mess with the order of these proteins. That is a big time problem. Okay, and that's how different issues in your body happen. So one of the ways that they do this, okay, yeah, it's almost like they have a matching shipping ID. So they're going to scan. Now, your body's like scanning system, okay, if this is called a codon, they have the anti-codon, the opposite, and they match, okay? They use their base pair rules to match. So they're going to say, okay, what's going to match up perfectly? So notice how, like, if I use this one, nope, it's not going to happen. It doesn't fit. If this guy tried to slide into the spot to drop off that amino acid, it's like of the incorrect delivery. Nope, get out. The ribosome's like, what are you trying to do, fool? Get out of here. I don't need you yet. This guy, however, perfect match. Codons and anti-codon. Remember, anti means opposite, so it's their complementary set are going to go together. Then once they make the perfect match, like, yes, then it reads the next one. CUG. And the guy out here is like, ooh, that's me. He comes in, he literally slides in here, makes that connection. And then that's when the two amino acids link together. And that tRNA that was here gets kicked out. And this growing strand starts to rip through and pulls and starts to travel through that RNA. Then it reads the next one and it keeps doing that. Oh, ACC. Okay, it's going to slide on there. It's going to ensure scan, beep. Good. Starts attaching the amino acids together. And it will keep doing this until it's completely done. Now, if this was our stop, okay, we like opposites in our world. So you have a codon, you have an anticodon, it's the opposite. If you have a start, you also need to have a stop. That's your release factor. So your AUG is your start codon. This guy down here, UAG, is your stop codon, which tells the ribosome, hey, you're done, and that's your protein right there. Now it's going to get picked up and it's going to get shipped off around the cell to be used for whatever its purpose was. Okay. Now remember, these guys right here, an actual protein or an amino acid strand can be thousands of codons. Okay, so it can be thousands of amino acids. We just did one with 3. So this code could literally be 3,000 bases long. And it's reading it in seconds. So it's like rips it through. All these tRNAs are fluttering all around, coming in and pulling it out. Like, it's insane how fast it happens. We'll show you some videos, okay, of real time. But basically, that's transcription, so making a copy. Translation is the process done by the ribosome because they're reading and translating the message from the mRNA, okay? All right. So I'm going to hold off on any of the other responses from your notebooks. I want to see what you guys came up with on those responses. Okay. But for today's activity, you guys are going to do a Nearpod. Now I know some of you, oops, I am way on the wrong slide. You guys are going to do a Nearpod, and so you're going to do slides 14 and 15 today. So don't worry about the extension that I had from yesterday. So from slides 10 and 11, it's going to get absorbed into tomorrow's activity. Okay, so I'm going to kind of go through this. So you are responsible for slides 14 and 15 today. I know that some people, the Nearpod is really hard on your computers. So what I have for you in Google Classroom, okay, is you're looking at lesson 4. The Explain Part 2, DNA to Protein Synthesis. Okay. Now, down here, you have the Nearpod that has everything in it. Underneath of the Nearpod, though, are all of the activities from the Nearpod. So if working in the Nearpod, it just is super tough on your computer, then I also put all the individual pieces that are in the Nearpod attached to the assignment. So you can work on each one individually. So you can watch the individual videos. Now the order that I would do them in would be the interaction or the interactive, okay, the CPOM one, the interactive notes, then the reading, then the videos. Okay, that's how it's presented in the Nearpod. Okay, so using that information, you're going to head to your notebook and you're going to be doing slides 14 and 15. So 14, you want to make sure that you can define transcription, list the main steps of transcription. So how is the DNA, what happens to the DNA first? How is an mRNA made? And then what happens to the mRNA? So you've got a little diagram here. And then what takes place during translation? So what is the ribosome doing? How is it translating that mRNA? And where do the tRNAs fit in? Then this diagram is part of the reading. So make sure you look at the reading, you'll see this, and you're going to drag these vocabulary terms into their correct location. So again, look at that reading section because that'll be on there, and we'll go through this and make sure you've got that down. Slide 15 is specifically about so starting looking at without all of the process steps. So how would you go from a DNA sequence to the complementary mRNA? And then this is where you're using what we call the codon wheel. So what do each of those little mRNAs code for? There is a video that has you go through it, and that's where on the extension, there's a video for that too. This piece, if the left-hand side of slide 15, you're like, this one's a little bit confusing, save this one for tomorrow and we'll go through this, okay? But you can definitely answer the right side. This would be from the last video, okay? You can do that from the last video. And this one's fun. So if you like puzzles and stuff, this is fun to do, okay? Questions on what's your goals for today? So slide 14 and 15 today. And then tomorrow we will go through all of it, kind of pull everything together. We'll have essentially 2 days of review. I know in your notebook it says you guys have a STEM Gizmo. I'm going to drop your STEM Gizmo. So this will be like, we're just going to practice for the next 2 days. We're going to get the info today, and then we'll have Wednesday and Thursday to put it all together and practice before your test on Friday. Okay? Yes. Tomorrow you'll have an exit ticket, Noah, and I'll have a little review question on there just to see how you guys are doing. And then I will have that question embedded in your exit ticket. So you let me know. No, Jillian, you are not going to be doing the STEM Gizmo for this one. I'm going to drop that assignment. So you will not be responsible for filling out that section of your notebook. You'll get no puts. Thank goodness. Yeah, no worries. I'm not going to do that to you guys for right now. We don't have enough time. And I don't want to extend it past break. Okay. All right, so you have today and then tomorrow. Yeah, so you essentially have today and tomorrow. And then the good thing about the elaborate activity, we're going to do the first half of it. And it's a really nice one, guys. It goes through a simulation where you guys will get to see it in action, moving through more real time. So it'll be a nice kind of bookend to seeing what happens after we kind of do some diagramming and stuff tomorrow. So yeah. So for today, you guys are going to get the rest of the class period to work through the Nearpod or the information from the Nearpod, your preference, you choose. And then using that information to complete slides 14 and 15 today. Okay, you may stay on the meet. You can work with your cameras, mics and cameras off if you'd like. I can put you into breakout rooms if you would like. I will be on the call until 1:45 today. So if you have any questions or you need any help, you can jump back in and I can walk you through that. If you want to email me, I can do that and get into your notebook if you need help in that way as well. Other than that, good luck. I will see you tomorrow. Bye, guys. And if you need anything, stay on, and I'm more than happy to help you one-on-one. Bye. Bye. You too, Raven. Treve, did you? I'm so sorry I missed you during intervention. If you were able to make it to intervention. Yes, absolutely. It is in Google Classroom. It just says mini quiz. It is still open. And did you get a chance to go to intervention today? I'm so sorry. Those last minute. Okay. Whew. Okay. So no worries. Check out intervention. And I have your assignment in there because it's just the one test. Okay. Because if we can take that, then that means I can do, so I have the Nearpod in there for you. So some things just to review. It's from photosynthesis, so from last quarter. But once you do that and we do like a quick review, if you take that test and you can pass it, like with like pass it, just pass, like with maybe like C, after we do a quick review and we can take it together, then I can do a grade change for you. And so you can get your credit for last quarter. Because that was the only thing that I was really, really missing from you was that test. Okay. So that's what we're going to be working on for intervention.